How fast are you going? You know how fast you're going? No idea.
Most people actually have a little bike computer, so they can tell what your current speed is. So those things are they're not expensive anymore. They used to be kind of expensive.
Yeah.
But these days, it's like, it's
These
not.
days you probably have an app on your phone.
Right.
You can plug it onto your little attachment onto your hand.
But then it'll catch you for using your phone while you're biking.
Yeah. Texting and writing.
Texting and writing, exactly. Well, in Davis, that's believable that somebody would actually enforce that. At night, when it gets dark, if you bike without a bike light, they will catch you for that too. They will actually give you a ticket. You have to pay for it. Okay, here's the row sheet, and let's go ahead and get started. The recorder's on, I'm pretty sure, because it's showing about the amplification. All right, so what we'll do today is we will finish up the discussion of pre and post conditions, because I need to finish this before we can have our first exam, okay? Because I want the first exam to include this particular topic. All right, so what we haven't really talked about is the rules, okay? How do we apply rules in order to make pre and post condition derivation kind of as mechanical as possible? And that's what we'll do today is, basically it's just to summarize what we have done up to this point. But instead of, doing everything on a case-by-case basis, we are going to make it more rule-based so that you just have to say, okay, which rule does it apply, okay? And all that stuff is in the notes already, okay? There's kind of, I would say they're kind of scattered all over the place, within here, but it is here. So what I will do instead is I'm going to give you some examples, kind of like a summary of everything. Okay, so here's the kind of more abstract description, and then we'll go back to the kind of concrete examples. So let's say we're talking about line number n, okay? So right off the bat, we have some abstraction here. I'm not even telling which line we're talking about, it's just some line number n, okay? And on this particular line number n, we have a variable on the left-hand side. We have the left arrow, which is the assignment operator. And then the other side, I would just say it is f of n. F of v, and v is the name of the variable on the left-hand side. Okay, so this is a really, really abstract way to describe an assignment statement, which is just expressing it as, okay, some variable v is getting updated. The expression on the right-hand side, we'll just call it f of v. Whether f of v has an inverse or not, we'll talk about that later. Okay? But for the moment, you can look at f of v as, it can be anything. So f of v can be defined as 0. That is a function. Okay? It's just that this function is very simple from a certain perspective, and there's no inverse. Okay? That's all. So we'll talk about this later. But f of v is just some kind of expression which may or may not involve the variable v itself. Okay. So the question now is, if we are given, okay, so given the precondition of line n, the question is, how do we derive, okay, the post condition of line n? That's the question, okay? Because I want to give you, some really, really mechanical rules, and you can just go, okay, step 1, do this, step 2, do this, and step 3, do this, okay? So step 1 is really to look at f of n, okay? So this is here is step 1. Step 1 is basically asking, does f of v have an inverse, okay? That's the first question. Some functions do, some functions don't. Okay? For instance, if you have f of v being 0, there's no inverse function because everything maps to 0. So knowing the result is 0 doesn't tell you anything about how I got there. Okay? Is that okay? So I'll just say that this function has no inverse function. Okay? It's not reversible. On the other hand, plenty of functions are reversible. For instance, if the function itself is just adding 1, which is very, very typical in a program, in an algorithm, that is reversible because the inverse function in this case is just subtracting 1. Because subtracting 1 is going to undo the adding 1 part. Is that making any sense? Sort of? Okay. So certain other ones are also reversible. If it is just multiplied by another number k, okay, assuming k is not 0, obviously. Okay, if k is 0, then we have the first case again. But in this case, there's an inverse, because if you are multiplying by k with function f, then the inverse is just dividing by k. Okay, it's reversible. Are we doing okay so far with how to determine whether the function f is reversible or not? Okay, all right. One really useful rule is if f of v does not mention v at all, on the other side, the definition of the function does not involve v, it is not reversible. Good? If f of v does not include v itself, so it can be x plus y, it is not reversible. How can you reverse it when the result of this function does not even involve the variable v? Yep.
Can you give an example?
Just like this. That is not reversible. That is not reversible. 0 does not mention v at all. But 0 can be disguised, right? Because v minus v is 0, yet it is not reversible. 0 times v also involves v, but it is also irreversible, because both of these basically map to a constant, maps to a 0. Is that okay? But for the most part, when we are actually programming, most assignment statements fall into this category for initialization, or will fall into these two categories when we are going through the code of a program. We're usually just adding 1 to something. Okay, it's not going to be a whole lot of complicated formula on the right-hand side. Okay, but that goes back to the first point. Okay, the first point is, does f of v have an inverse? Does the function f have an inverse? So based on that, we have two ways to proceed. Okay, so I'm going to call this 2. Okay, if there is no inverse. Okay, if there's no inverse, then we are kind of in a disadvantage, because everything that we knew about v, we have to forget it. Okay, we can no longer keep what we knew about how v relates to other variables for the most part. In certain cases, you can kind of still attach something to it depending on what is on the right-hand side of the assignment, but in general, the answer is no. So if that is the case, then we conclude that the post condition of line n is the following. Okay, I know this will look kind of confusing, but we'll talk about this with certain examples. So we say forget, okay, which is basically just an operation. Okay, forget is an operation. It is just taking out certain components in an expression. So we're basically saying, okay, let's look at pre-n, the precondition of line n, and out of that whole thing, let's just say that everything that we know about v, we have to forget. It's just the syntax. This is just a syntactic way to say that, okay, we'll go through pre-n, the precondition of line n, and then whatever mentions v, we have to get rid of it, because we can no longer relate v the same way that we did to everything else. Is that okay? Just conceptually, is that okay? Okay. All right. So I'll give you guys an example. Let me just kind of, okay, who has not, okay, so we missed it, almost the entire section here. I think it passed from the back to the other side, and I'll make sure that you get it too. Okay. So now the other question is, if there is an inverse, okay, then what do? Well, we look at the post condition and say the post condition is the result of applying a substitution operation. The substitute operation has 3 components. The first component is, what is the original? The original is the precondition. Then we specify what is getting replaced. Any mentioning of v is going to be replaced. Then the third component specifies what are we replacing it with. That would be the inverse of f applied to v. In other words, if f is inverse, it has an inverse, it is reversible, then we can basically say, we know what line n did to v, so if we can reverse that operation, then we can re-establish all the relationship between V, the old value of V, with everything else, with all the other variables and with all the other constants. Is that okay? It's based on what we have already talked about, just in a very abstract way. Is that okay? So far, any questions?
Could you repeat that part one more time?
As much as I want to, I cannot because I cannot remember what I just said. But it is in a video, right? So we can play the video again. This is like TiVo, but in the class. So today is the 0222 cisp300, and I can actually play the video while it is being recorded. And we'll skip to the part over here and crank up the volume from the computer. Let's see. Well, it's supposed to be on already. So how come there's no volume? Oh, the devices. Is that okay? It's based on what we have already talked about, just in a very abstract way. Is that okay? So far, any questions?
That's all. Can you go back?
As much as I want to, I cannot because I don't remember what. And I can imitate the TiVo sound. It's in a video, right? So we can. So far, any questions? All the relationship between V and V is going to be replaced. The third component specifies what are we replacing it with. That would be the inverse of F applied to V. In other words, if F is inverse, it has an inverse, it is reversible, then we can basically say, we know what line N did to V, so if we can reverse that operation, then we can re-establish all the relationship between the old value of V with everything else, with all the other variables and with all the other constants. Okay, I think that's what you were asking. It's based on what we have already. Is that it? Okay. Isn't that cool?
Yeah.
It's like a time machine, but less expensive. I don't need an imploding star as the energy source, like a TARDIS. If you don't know what a TARDIS is, you have to start watching Doctor Who. Great British, sci-fi. Okay, so getting back to, I almost lost track. Okay, there we go. So this is just syntactically saying what needs to happen. Okay, so this is the structure. Okay, the first step is just to determine whether the right-hand side is reversible or not. Second step depends on the answer to the first question. Okay. If it is not reversible, then you really don't have a whole lot of choice but to remove what you already knew. And, okay, I forgot one thing here. But you can also say one thing new here, because now you know for sure that this relationship has to hold because we just changed the variable V based on f of V. Even though it's not reversible, we know they are the same now. Okay, so you have to add that one little extra piece at the end because we know that. And then one more time, okay, we talked about this already. This is an equal symbol. It cannot be an assignment operator because we are now stating, we are basically asserting that V is f of V at this point. Okay, so we cannot use a left arrow. The F arrow, the left arrow, the left arrow means assignment. It is an operation. It changes the whatever variable specified on the left-hand side to the right-hand side. We are not changing it anymore. We are now stating that it is the same. The two sides of the equality is the same. Yep.
So it's not saying forget the second statement, the V equals F of V, that's just separate?
Say that again?
So it says forget V and V. Are we also forgetting the second statement?
In the substitution?
V equals F of V.
This is not a part of it's not inside the forget, this is outside of the forget.
Okay.
So you apply that after you forget what you knew before, and then you attach one extra fact and say that, oh, but we know at this point the v is the same as f of v. Okay? Now I know this is all abstract, but the abstraction helps us because now we can just use this as a pattern and then we can solve problems. So we'll go ahead and take a look at a few examples. The first example is on line 46, we have the following code. We have x gets x plus 1, okay? And we, for whatever reason, I tell you that the precondition of line 46 is, the first thing we know is x is less than k, okay? Don't ask me why, I just know for sure that right before line 46 executes, we know that x is less than k. We also know that if z does not equal to k, or z does not equal to j, let's make it j. And there's one more thing that we know, which is a complicated thing, okay? We just say that x plus 2, the whole thing times y equals to w. There we go. Okay. So this is all made up, okay? Obviously, you know, but it's just saying that, okay, there are certain things we know about how the variables relate to each other before line 46, okay? Nothing is really held down by constants, but that's not the point. I don't need everything to be held down by constants. I just need to know how the variables relate to each other. Equal to, not equal to, less than, greater than, and so on. So now the question is, how do I apply those rules that we just, you know, talked about? Step 1. The step 1 is, okay, f of x in this case is what? What is on the right hand side? X plus 1, very good. So now the question is, do we have an inverse function? Can I reverse that? Okay, I have to hide my own answer here. Is it reversible?
Yeah.
Yes, okay, very good. And if it is reversible, what is the inverse? Okay, good, very good. So that means, do we use step 2 or do we use step 3? Use step 3, very good. Okay, so now we apply step 3. So step 3 basically says the post condition of n, and n is 46 in this case because we are talking about line 46, is the result of applying the substitution operation. The substitution, okay, so without expanding anything, I'm just gonna say, oh, we are substituting components inside of the precondition of line 46, we'll expand it later. What we're looking for is the variable on the left-hand side, which in this case is x, and we're replacing every single instance of x with f prime, which is the inverse function of f applied to x. Do we have any questions at this point? Because I just applied, mechanically, I just applied the rules that we talked about earlier. Yep.
I have a question about step 3. When you have the sub pre-ed v f prime v, do you not need and v equals to f of v?
Nope, you don't need that anymore.
Yeah.
Because once we know it is reversible, we keep everything, and we don't need to add anything to it. Okay, so let's see how well it works here. Okay. All right. So the next step of step 3, okay, is actually to expand everything out. In other words, we're going to say, do we know what is the precondition of line 46? It was given to us, wasn't it? So what we do is we just go like, oh, it's this big, huge mess here. Well, it may be a big mess, but it's okay. Just copy and paste it here. We're still replacing every single instance of x with something, but what is f prime of x? I'm going to put it inside parentheses, just so that we won't have any issues with a priority of operators. What is f prime of x? X minus 1. There we go. Are there any questions about the step 2, okay, or step B of 3? Where the blinky cursor is. It's nothing more than just expanding every single term, right? We're expanding what is the precondition of line 46. We're just expanding what is the inverse function of f applied to x. Is that okay? Fairly mechanical. I'm hoping that this is really kind of mechanical and going, oh, okay, we just copy and paste a few things. And that's exactly what I did. Step 3 is to go through the actual substitution, which is basically saying, okay, this is really the same thing as in a word processor. You just say, okay, find every single instance of something and replace it with something else. So if I want to do it with just a text editor feature, let me see if I can do that here, okay? I'm just going to copy and paste it here, select the entire thing, and then go to the text editor thing and say search and replace, which is search, find and replace here. So what I'm doing is I'm just going to find all occurrences of x, replace all occurrences of x with, in parentheses, x minus 1. The only reason why I specify open and close parentheses is because I don't want the priority of operator to be wrong in this case. So if this thing is next to a multiplication, I don't want it to mess up the multiplication. So if it is in parentheses, then I know I'm good. Is that okay? So the parentheses is really just for that purpose. Search direction is down, and we want to replace all in selection, but somehow my selection is lost. Okay, so I have to do it again. So select this whole thing, go to search and replace. Oh, it doesn't let me only do that part. And it crashed. I just lost the text document. It's okay. Well, I have it in the recording, so I can potentially go back to the recorder. But let me see if I can. Okay, I didn't copy, so it's really lost.
I have it written down. Have it written down.
I think. Okay, go ahead.
The whole line.
I just need the last one. The substitution is, I think it's x is less than
k,
Uh-huh.
and z is not equal to j, and x plus 2 times y.
Is that it? Okay, so that's the precondition. We're replacing all occurrences of x with x minus 1. Okay, fine. This time we'll do it by hand, because apparently this editor doesn't have that feature, so we'll do it by hand. It's easy. Look up every single x here. Here's 1, replace it with x minus 1. Here's another one, replace that by x minus 1. And you might say, oh, we can simplify that. Yeah, we can simplify it. But at this point, I don't even need you to simplify. Just mechanically apply the steps. Okay? And I can tell you that this is right. So after line 46 executes, this post condition has to be true, given the precondition is true to begin with. Is that okay? But does it make sense? I mean, mechanically, this is what we are doing, but you kind of have to think about, does it make sense that we can do something like this to preserve what we know about the precondition and carry it on to the post condition? Does it make sense? It does, right? Because the only thing we did to x is we increased it by 1. So by decreasing the new value of x by 1, we got back the old value of x. But the old value of x was less than k. So that relationship is still holding. With this one, nobody changed z or j in this assignment statement. So, so if they were different to begin with, they have to be continue to be different. In this case, I knew that x plus 2 times y equals to w. That's before the assignment statement. That's before I add 1 to x. Now that I have added 1 to x, if I subtract 1 from x, I got the old value of x back. What did I know about the old value of x? X plus 2 plus the whole thing times y equals to w. So that's why this technique works. And there was a question.
Yeah, I don't have it anymore.
Oh.
Yeah.
So did you forget, or it's resolved?
It's resolved.
Okay, good.
I have a question. What would happen if z did not equal to w? Because that's like a 3-variable manipulation. Like, how would you write that out?
That's a very good question. Okay, so the question is, okay, so I'm just going to copy and paste this. Okay, so the question is, what if the precondition is not the same as what we have here? So let me just kind of copy and paste this a little bit, and then we can talk about it. Okay, so you want to add one more thing? And
Well, I just was replace Z does not equal J with W, so all three are connected to each other.
Okay.
And how would that change how you write out Z does not equal W?
Okay, it would still be the same.
Because W was changed from X.
W.
Over here on the right one, is X, the relationship between X and W was changed because X was added 1, right? So that would change the relationship with Z and W, wouldn't it? Because W was added 1.
Okay, did I capture this correctly, that Z is different from W? You were just
In my
changing the J
question.
to a W, right?
Yeah, yeah. I was just seeing how you would write, how that would change.
Then it would just be the same,
Okay.
right? It would, this would still be true. I mean, you're not really adding anything to what we already have here. Because the assignment statement, let me just kind of go back and talk about what line 46 looks like. It's really just X gets X plus 1. So if X is the only variable changed, if Z was different from W, it would still be different.
But W is 1 more now.
No, W has not changed. X is now 1 more.
Well, W is the result of X plus 1 plus 2, right? Because
You
we're adding
mean,
X plus 1.
you mean because of this?
Right. That's the precondition.
But
Then
that's
you're adding
the-
1,
but-
so that would be adding 1 to W, wouldn't it?
No, because this is based on the value of X before line 46. And then this is based on the value of X after line 46. Is that okay? So all the pre and post conditions refer to the value of the variables right at that point, either as a precondition right before a particular line executes, or as a post condition right after that line executes. So it's not a constant relationship, it's really just at that time, how do these values relate? Any other questions about this one? Yep.
So on the next line, would W be different? And you'd have to update that? Like
On the next line?
You did like 47 or wherever this line led to.
Well, line 47, okay, assuming there is a line 47,
Yeah.
so what you do is you say that the precondition of line 47 is the same as the post condition of line 46 because it is right next to it.
So if you're reassigning W something.
Okay, let's take a look. Okay, so now we'll go ahead and illustrate the other rule. So let's say on line 47, we change W. Okay, we say W equals to, W gets a value of IJKL, let's say M, okay? And we don't even know what M is, okay? All right. Okay, so we apply those rules again. Step 1, what do we do in step 1? Step 1 takes a look at the right-hand side. In this case, it's f of W. Okay, f of W is defined to be M because that's what we have on the right-hand side. The question is, does it have an inverse? Can we reverse this operation?
Yes.
Remember what I said? If the right-hand side does not even mention the variable on the left-hand side, it is not reversible. There's no inverse. So in this case, M is just some other variable. It doesn't mention even W. So it is not reversible. There's no inverse function. Okay? So you have to kind of state that this has no inverse function. Okay? There's no inverse. Because it has no inverse, which step do we go to? Do we go to step 2 or step 3 from the previous discussion? We go to step 2, which is the forget operation. Okay? So now we apply step 2, and if you look at step 2, unfortunately, the text editor crashed. But what it looks like is the post condition of line 47 is based on forgetting something in the precondition of line 47. What we are forgetting is everything that we knew about W. But on top of that, there's one new thing that we know, because from here on, we know that W and M are exactly the same. That is the result of applying step 2, except in this case, it is concrete instead of in the previous slide where it is kind of abstract. Is that okay? So I'm still mechanically just doing, I'm still doing everything mechanically. So the next step is to expand what is line 47 inside the forget operation. So we'll just kind of copy and paste this entire thing, except this time we'll look at line 40. We'll look at the precondition of line 47, But we know that the precondition of line 47 is the same as the post condition of line 46 because those two lines are sequential. So we know it is just this mess here. That is our pre-47, or the precondition of line 47. So we just need to attach that thing here. So this is the real operation, is how do we forget something? Well, you just look at each individual statement and say, does it mention anything about W? What about this one? Doesn't say anything about W, we keep, okay? So we say x minus 1 is less than k, we keep, because it doesn't use W at all. What about the next one? Does it say anything about W? Yeah, it does. We cannot keep it. What about this one here? Does it say anything about W? Yes, it does. We cannot keep it. So those two we are forgetting because they mention something about W. But on top of everything else, okay, so we only keep one out of the three components from the precondition. But there's one more thing that we add to it, which is W equals M, because we know for sure that right at this point, right after line 47 executes, W and M, they must be the same. So that's the application of the forget operation. Do we have any questions about the steps of applying the forget operation? Yeah, go ahead.
Why did you copy and paste all that stuff from post 46?
Because post 46 is the same as pre 47, and that's what we are applying the forget operation to. Yep.
So, on the forget operation, when you go to the next line, what if it calls for something that was in the previous line that was forgotten, like K? You know, how does the program know, or the algorithm know to go back to not the previous line's value, but the previous value of K?
You just don't lose. You just lost everything that you knew about. Those variables still hold their value. You just lost track of how they relate to each other.
In that line.
On that line. So this is not tracing at all. This is really just confirming. We're just stating what do we know for sure that has to be true when this line executes. So it's not tracing, and I intentionally did not bind anything to constants as a result, because if I bind it to a constant, then you might think, oh, it's just tracing, but it's not. Any other questions? Any other questions? Yep, go ahead.
We are doing the pre and post conditions for a test or an assignment.
Mhm.
Should we leave it as forget x minus 1 is less than k, or do you want it to be simplified to what the last line says?
Not simplified, but just to apply the forget operation. So I need all three steps. Okay, so the first, I need all of these. So I need the rationale. In other words, you have to tell me why you choose to use forget or why you choose to use the substitution. So the first question is important because it helps you decide which way you're going. Now when you decide to use the first or the second step 2, then you have to give me this kind of overall thing. It's like, okay, what are we forgetting in which precondition and what is added to it? And then you expand it. The second line is really just expanding what is the precondition. And then the third line is the result of the actual application of the forget. So I need all of these when you're doing your homework. Okay, that's a very good question. Okay, any other question? Yep.
Like on the homework, how would we know we would be doing the inverse rules?
You just state, just like what I did here. You basically say, this is the definition of the function, and then you say it has no inverse when it has no inverse. But when it does have an inverse, then you say it has an inverse of, and then you define the actual inverse function.
How would we know we'd be doing this procedure for, we would just be given M is assigned to W, right? For the homework problem?
Right.
Okay.
But then but because the right hand side does not even mention the left hand side, so you know for sure that it cannot be reversible. There's no inverse. All right. So let's do a few examples. Okay. So I'm going to go through a few examples here in class, just so that we can get a little bit more familiarized with this. So let's say we start off with line 23. For no particular reason. So on line 43, we just say, okay, x gets a value of k. On line 24, we say x gets x times 2. On line 25, we say y gets x plus 2, okay? And on line 26, we end up saying, y is also doubled, okay? We'll add some more to it. So we'll just say it's doubled, and then we plus, we add 10 to it. Okay, so these are the 4 lines that I'm dealing with here, and we'll have to start with the precondition of line 23, right? So we say the precondition of line 23 is we already knew something about x, y, and k. So we'll say that k does not equal to z, and x is already known to be 6 times k. And we also know that x equals to y plus 2. Okay. For no particular reason, it has to do with the other lines before line 23. So these are the things that we knew about the variables right before line 23 executes. So what do? Well, we apply those rules that we have just talked about. Step 1, we look at the right-hand side, and then we say, is it reversible? Okay, so step 1 is basically to say, on line 23, the function of f of x is just k itself. And then we say it has no inverse. Is that part okay? Okay. But because it has no inverse, we have to use the forget operation. So then we say we apply step 2, and in step 2 we say the post condition of line 23 is applying the forget operation, and then we can state one more thing, which is x and k must be the same at this point. And the forget operation has 2 things to specify. The first one is to specify the precondition of line 23, which is where we start off with, and then we have to specify what are we forgetting, things containing which variable are we forgetting. So what do you think it should be? Should we forget everything that has k, or should we forget everything that has x? X, because x is the one being changed. So we have to say forget everything that has x in it. Alright, so now we actually expand what is pre-23. So for the most part, I just copy and paste it here. Now, one important part is to remember this and x equals k is outside of the forget operation, because it doesn't make any sense for this to be inside the forget operation. Otherwise, it's self-defeating, right? Because we put it in something and then we immediately have to forget it. So remember, this is outside of the forget operation. Okay, the third step is really just to apply the forget operation, which in this case is to say, oh, k does not equal to z, we can keep because it doesn't say anything about x. The next one we have to forget because it does mention something about x. The last one we also have to forget because it mentions something about x. But on top of that, after forgetting 2 things, we also have to add x equals to k because that's the result of this assignment statement. Do we have any questions about the derivation of the post condition of line 23? So I'm hoping this is fairly mechanical. Okay, it's just, okay, step 1, do this. Okay, based on the result of step 1, we either use the forget operation or we use the substitution operation. Okay, pick one of those 2, and then we just mechanically apply those operations. Now we focus on line 24. But before we do that, we can say pre-24 equals to post-23 because these 2 statements are consecutive. So the post condition of the first one becomes the precondition of the second one. It just makes sense. Now we look at line 24, and we repeat the same steps. Step 1, we look at the right-hand side, which is f of x equals to 2x, or 2 times x. Does it have an inverse? Can we reverse that operation? And how do we reverse that operation?
X over 2.
X over 2, exactly. Or 0.5 times x, however you want to say that. We just say x divided by 2. Is that okay? Does everybody agree that 2 times x as a function of x has an inverse of x divided by 2? Because if you double something, you can undo it by taking 1/2 of it. Is that okay? Okay. Then we, based on what we observed in step 1, now we go to step 3 instead of 2 because it has an inverse. So in step 3, we basically just say, okay, the post condition of line 24 is the result of applying a substitution operation. What we are substituting, okay, the source is the precondition of line 24. What we know before line 24 executes is where we start off with. We replace all occurrences of the variable on the left-hand side, which is x in this case, with f prime or the inverse function of f applied to x, because that's basically an undo. On the second line, we just expand out all the terms. We already know this is the precondition of line 24, so we stash it here. And then we know this is the post condition, we know this is the inverse function applied to x, and we stash it over here. I just put extra parentheses for the same reason that I talked about earlier. And on the last line, we simply carry out the operation. K does not mention anything about x, no need to change. Z does not either. And over here, well, we got something that does mention x. So we have to say, okay, x divided by 2, because that's the substituted value, equals to k. Is that okay? Does it make sense? Because x divided by 2 equals k is the same thing as saying x equals to 2k. Does that make sense? Okay. Now the best thing about this type of derivation is it is not tracing. It's just using mathematics to derive the condition of the pre or the post condition of a statement. There's no tracing involved. I don't even know what k is supposed to be. It doesn't matter. If it was k before, now it's 2k. That's all. Is that okay? All right, so we move on to line 25. So we basically have to say pre-25 is post-24 because once again, these two lines are consecutive to each other. So the post condition of the line before becomes the precondition of the line after. And then we repeat the steps. Step 1, we look at f of y, in this case, is x plus 2. This looks a little bit tricky because it seems like, oh, x times 2 has an inverse, so x plus 2 must have an inverse. But that's not the case because this is not a function of x, this is a function of y. So if f of y is x plus 2, does it have an inverse? Nope, because the right-hand side does not even mention the left-hand side. Forget it, doesn't have an inverse. So then we just say that it has no inverse. So we have to apply step 2. Step 2 says post 25 equals to forgetting something in pre 25, and what we're forgetting is anything that mentions y, not x. Okay, remember it is the variable on the left hand side, the one thing that is being changed. But after this, we will know something about y because of the assignment statement. Because after this, we know y equals to x plus 2. Do we have any questions about this step? This is really just mechanically applying what we talked about earlier. Okay. If you're thinking this is really boring, this is so mechanical, it is really boring, congratulations, you're getting it. Okay? Because we are just doing something repetitively. It's like the same thing over and over again. Okay, so the next step is really just to copy and paste. Okay, copy, that's our precondition. And we're forgetting everything that mentions y. But after the forget operation, we can add that one little fact here. Okay, k does not equal to z, doesn't mention anything about y. We can keep that. X divided by 2 equals k, also doesn't mention anything about y. So we can keep that too. So now we have this. Are we doing okay so far? Now, this is kind of like a tricky part. The tricky part is we can see that the second condition and the third condition, they are kind of connected. Okay, I'm hoping that you guys can see that. If you look at the second condition, which is this one here, it kind of defines what k is. But you can also say that this defines x is 2k. We can apply that over here, right? So what I would do is to expand it. Okay, sometimes it's not useful to do it, but most of the time it is. So what I'll do is I'm going to say, oh, let's go through all the gyrations and figure out what are the other ways to express this. So I can say, oh, you know what? Because I already know x equals to 2k, I can re-express this as y equals to 2 times k plus 2. Is that okay? Does everybody understand why I can substitute this x with 2 times k? It's because of the second condition. Is that okay? Okay. Which doesn't seem to be useful at this point, but it will become useful in certain cases. I think in this example, it never becomes useful. Okay. Then we have line 26, which is, well, it's kind of an interesting one, so we'll take a look at this one. Okay, the first thing is to connect what is the post condition of line 25, which is what we just figured out, to be the precondition of line 26. That's just because these two lines are right next to each other. And then we ask the questions. Okay, step 1, we look at f of y being 2 times y plus 10. Okay, and we ask, well, is it reversible? Can we know the new value and be able to reverse the operation? And what would that be?
1/2 y minus.
Okay, so this is where what you learn in calculus may come in handy. Okay, because we have a compound function here. So with a compound function, which means it can be separated into two simpler functions, the inverse would be applying the inverse function but in a reverse order. Which means if adding 10 is the last thing that we did, we have to do it first. We have to reverse that first. So it becomes y minus 10, and then the whole thing divided by 2. Okay. But nonetheless, it is reversible. So it is y minus 10, the whole thing divided by 2. Because you have to undo it in a reverse order. If adding 10 is the last thing that you did, you have to reverse that first. Is that okay? Does that make sense? Sort of? Okay. All right. But since it does have an inverse function, then we have to use the substitution rule in step 3. So now we just mechanically just say that post 26 is the result of applying the substitution operation based on the precondition of line 26. What we are finding or what we're replacing are occurrences of y, and we're replacing each one with f prime applied to y. Completely mechanical. And then the next step is also kind of mechanical because we just copy and paste. Copy the precondition, and then we copy the inverse function of f applied to y, and put parentheses around it. And then the next line, we just apply the actual substitution operation. So this one is a little bit longer, okay? So we'll copy and paste it, and this time I will use copy and paste as a feature. So every time we see y, we replace it like that. In this class, I don't need you to simplify, okay? If it ends up to be kind of messy, like what we have here, let it be, okay? It's not a big deal, okay? In this class, it is all about, do you know whether a function has an inverse or not? If so, what is it? And then based on that, do you know whether to apply the forget rule or apply the substitution rule? The third one is, okay, apply the rules, okay? I don't need simplifications. It does get messy, but that's okay. It's not a big deal. Are we still doing okay at this point? Yep. Okay, so I have a question. Remember, I injected one more fact into the whole thing. Remember, okay, let me just point out using the text editor here. Do you remember that I injected this last part here? Injection means it wasn't there to begin with, but I can infer that that is true. And I just added that part and go like, well, it might become handy later on. So let me just add one more line to this original code to make it actually useful, okay? So let's say we have a line 27 now. So on line 27, we are resetting the value of x to, I don't know, let's put it to 0. We are reinitializing x. let's see what's gonna happen here, okay? Let me stretch out the screen a little bit. I don't think it's gonna help that much because we're too far down already. So I'm just gonna put this code and repeat it over here, so this way we know the context. There we go. So now we want to go through the same steps. We just define f of x being 0, and we say it has no inverse. Okay. So that forces us to use step 2, which is the forget operation. Oh, we forgot one thing. We say pre-27 is post-26 because those lines are right next to each other. Now we can say post-27 is forget pre-27, and we have to forget everything that we knew about x or how x relates to other variables. And then after that, we can say x is now 0 because we just put a 0 into it. Okay. So the next step is really just kind of mechanical because I'm just copying and pasting this junk into here, and then we say we forget everything that we knew about x. Okay, it's a little bit too long, but for the most part, I think you guys know what it is. It's just the copy and paste. You know, it's getting a little too long. Are we still doing okay so far? I'm still just blindly applying the forget rule. But here's the magic. Okay, so let's see how much we have to take out and how much we can retain. So after the forget operation, we keep k does not equal to z because it mentions nothing about x. But you know what? This one I cannot keep anymore because I just reinitialized x to 0. So I can no longer maintain the relationship between x and k. I cannot keep this one either because I just changed x. So the relationship between x and y using this kind of complex equation does not hold anymore. But you know what? Because of that one extra step that I took earlier, by deassociating x from y, I now can keep that one. Even though originally it depends on x, I did one extra step to decouple the relationship between x and y. Instead, now it is between y and k, and because of that, I can keep it. And then the last one is just x equals to 0 because of the assignment itself. So that's why it is useful to inject this one extra step earlier. Whoops, I clicked the wrong one. This one here, because it's saying the same thing. Okay, it doesn't add anything new at that point in time, but later on it became useful because I had to toss away everything that I knew about x. Now it doesn't mention x anymore. It is relating y directly to k, so I can take away all the components that talk about x and still retain that one. Is that okay? Are there any questions? No questions? All right. How is doing some analysis like this useful in programming? Okay, we have already talked about why pre and post condition and all this math stuff is useful when you are pursuing the holy grail. Okay, and the holy grail is automated program verification, right? But that's kind of a really high level objective. It's unlikely that we can attain that in the next 5, 10, 50 years, okay? So what is the practical application of analyzing a program the way we just did?
Identifying bugs, errors.
Sorry? Go ahead.
Help identify bugs, errors.
You can help find bugs. Okay, very good. Okay, and what exactly are bugs in programming?
Unintended behavior.
Unexpected behavior or behavior that is deviating from what you think the program should be doing. Okay, that's good. But how do we know your program has a bug? How can that be observed? Because if it cannot be observed, you don't know the program is buggy, right? So how can a bug or a mistake in programming manifest so that you can see it? Program crashes, right? Go ahead. Errors, okay? Or it does things that it is not supposed to, okay? So you can do some calculations, and the value that it comes up with is wrong. Okay, you can go through your own manual calculation and go like, no, that's not supposed to be the answer. So the program is not doing whatever, it's not doing something right. How do you debug a program? Very carefully. Okay, so that's good. You're describing the attitude. Okay, that's good. But mechanically, how do you debug a program? You go back and take a look at the program. Okay, let's forget about programming. Your car is not starting this morning. What do you do? Besides calling the mechanic or AAA.
Go from the start and see
Open
where.
the hood, check
where
the.
Aha, okay, so you guys have certain things to test, right? In other words, out of one single symptom, okay, the symptom is, okay, I turn the key and then nothing happens, or the car doesn't start, okay? That's the most immediate symptom. And you start with that, okay? You don't go take a look at your catalytic converter when your car doesn't start. Doesn't make any sense. You don't open up the door and see if the electric motor to crank up the window is working or not. It has no relationship to whether your car starts or not. Well, actually it can relate, because if there's a dead short and it drains your battery, your car won't start, right? But that's not the first thing you do. Okay? It's the same thing with debugging a program. You start with the most immediate symptoms, okay? What you can observe. And then where do you go? How do you go backwards with diagnosing a car problem? How do you go backwards? You start with a symptom, okay? The car doesn't start. Then what do you think? You think, what do I need for the car to start? I need gas, okay? I need the battery to have a charge. I need the electrical connection from the battery to the rest of the car to be intact. If your car battery terminal is eroded and it doesn't make a good connection, your car won't start. I need the starter to be working. I need the relays to be working. I need the ignition key itself to be working. So there's a whole chain of stuff that needs to be working for your car to start. So what do? You start with the easiest one to observe, right? You start with, oh, okay, I can access the battery pretty easily, use a voltmeter, check it. Okay? Even though it is not likely that your battery is dead, just because it's easy to check, do it first anyway. You can check the connections, okay? Just physically observe and stuff like that. So there are certain steps that you do that you trace your problem backwards. With programming, it is the same way. If your program doesn't work, you try to execute a program, quote unquote, backwards. So what? How do you execute a program backwards? It's not possible. It is possible if you analyze the code in a mathematical way. Okay, so let's start with this, okay? So what I'll do is I'm going to go through the same code here. Okay, so we'll start with this code. And this time, instead of giving you the pre-condition of line 23, I give you the post-condition of line 27. And then we'll try to work our way backwards and see, well, can we find out as much as possible, how much can we find out about line 23, okay? And I have to be careful here because certain values will work out and certain values won't work out. Okay, so I will say the post condition of line 27 is x equal to 0 and k equals to 3 and z equals to 47. And with x and y, I have with y, I have to be particularly careful. So I have to kind of. Okay, let's not know anything about k. Okay, that's because that's what we want to find out. Okay, and let's see. 6, 8, 26. Okay, y equals 26. Okay, so when the program does crash, this is all we know. Okay. So the question now is, how do we execute a program backwards so that we can derive pre-23 from the post condition? Now this is all about debugging. This is debugging. This is no longer about program verification. Program verification is only going forward. Okay? We're going backwards. In other words, these are the things that we can observe. Okay, maybe it's printed. Okay, maybe you can go into the debugger and find out certain things. But these are the things that we can observe. The question is, based on what we can observe when your program is misbehaving, can we execute the program backwards and figure out, okay, by the time we get back to line 23, this is what we know about K. Yep.
So like when Firefox crashes, it's in the post conditions as the error reporter or whatever.
Mhm.
Essentially, I mean, I'm sure it's more complicated than that, but
It's just more complicated, but each post condition is really just saying, okay, something has failed. When Firefox crashes, does it say post condition is not true? It is invalid?
It just says error, you know, crashed in error report. I'm just asking if that's like this is the concept of what the error report is. Essentially, is this is where the program
Sort of.
crashed, and these
Right.
are the conditions. And then
When Firefox crashes, it probably only tell you where it crashed, but it won't tell you much about the variable values at the
Right.
time it crashed. Maybe it does, maybe it doesn't. Depends on when it sends a report back to Firefox.
but this is what the report is.
Yeah, yep. So the developers has a chance to go backwards and go like, how did we get to this state?
Well, yeah, because that's one certain test case that was already proven to fail.
Yep.
That they already have the data for, right? And then
Right.
this is essentially the data that they're getting. So
Yep.
that's-
They start with this and they try to diagnose at which point did I make a wrong turn, basically. Okay, so let's see if we can work on this backwards, okay? Based on this, what can we say about the precondition of line 27? I just need you to use just reason it out. You don't need to use the rules that we talk about, just reason it out, okay? Hmm? Well, the only thing we know is we don't even know whether x equal to 0 or not before, because we just changed it to 0. And 0 is not reversible. So there's nothing we can actually say about x prior to this line. So the only thing we can keep is, okay, z equals to 47, we can keep because we did not change z. And then the other thing is y equals to 26, we can keep that too because we didn't change y. Is that making any sense? We lost the knowledge of x equal to 0 because it is not reversible. Even though we know that x equal to 0 right after line 27 executes, there's no way that you can tell what x was before that line. And that's why I have to take it out, because I can no longer confirm that x equal to 0. Is it possible that x was 0 before line 27? Yes. But is it always the case? No, probably not. And that's why I can no longer assert that x equals to 0 as a precondition of line 27. Okay, now this line is a lot more interesting. Okay, line 26. Now that we know that line post 26 is z equals to 47 and y equals to 26, is that reversible? It is reversible, okay? Because we know that 26 is f of something, okay? Some f of some original value of y, right? But it is reversible. So that's why we can now say, okay, what if we apply the inverse function of this f on 26? That will get us the original y. Okay? So if we go back to this step here, we already know the inverse function of the right-hand side of line 26 is y minus 10 divided by 2. So let's apply here. So now it is 26 minus 10, and then the whole thing divided by 2. So that becomes 8. Right? 26 minus 10 is 16. 16 divided by 2 is 8. Oh, that means I can now say the precondition of line 26 is z equals 47. That one I'm not changing because that particular line did not change z. But we know that y is 8 prior to line 26. Is that okay? That's reversing. Okay? We are reversing the execution of the program. But based on that, can we do something about line 25? Okay, so we say post 25 is the same thing as pre 26 because we are just going back one step. Now the question is, do we know anything about pre 25? This is line 25. After line 25, y ended up with a value of 8. How can that happen? Now we know these two still has to be true, right? Oops, copy, paste the wrong thing. Okay, so we know that z equals to 47 is still true, okay? We know that y equals 8 is the result afterwards, but it is the result of x plus 2. So what can we conclude at this point? X equals 6, but we lost track of y. We can no longer confirm y equals to 8 prior to line 25 because we changed y in an irreversible way on line 25. Is that okay? This is running a program backwards using mathematics. And once we know what is pre-25, then we can go back to post-24 being the same as pre-25 because these two lines are right next to each other. So we know that x ended up with a value of 6 after line 24. The question is the function on the right-hand side of line 24, is that reversible with respect to x? Yes. It is, okay? And how is it reversible? Divide by 2. So that's why we can say, oh, okay, now we can derive the precondition of line 24, z equals 47, we can keep all that, and x equals to 3, because it's halved because of that. Because after doubling, it is 6. Well, before the doubling, it has to be 3. Is that okay? So now we can finally get back to the first one. We can now go to post-23 is the same thing as pre-24. So we know the post condition of line 23 is this, okay? Line 23 is really just initializing x with k. So what can we conclude as the pre of line 23? Z equals 47 and k equals 3. But we can no longer say that x equals 3 because we changed x in an irreversible way on line 23. So just knowing that after line 23 x has a value of 3 doesn't say anything about x prior to line 23. But because of the way we link x and k, because of line 23, now we can establish and say that k equals 3, must be 3. So this is why it is helpful to analyze a program backwards, okay? Because we can now figure out, okay, from the symptom, which is what we started off with as post 27, now we can push back 5 steps, okay, and say that, oh, before this chunk of code, we know for sure that k has a value of 3. Now, whether that is correct or not depends on the rest of the program and what the program is supposed to do, but at least we're able to go backwards. And that is debugging. Are there any questions about what I just did here? Does it involve really heavy-duty math? No, but it does involve reasoning. Okay, there's a lot of reasoning when it comes to debugging a program. Okay, I will not ask, okay, who likes debugging or who like diagnosing problems, because debugging is basically starting with a problem and find out why there is a problem to begin with. Okay, there are 2 types of developers: programmers, engineers, software engineers, and whatnot. However you want to call those people. The first type hates programming, hates debugging. Okay, they like programming, they like writing new code, but they really don't like debugging. Okay, the program doesn't work. Okay, fix it. Oh man, this is the worst kind of task. Blah 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 blah. And then the other type, obviously, like debugging. Okay, so now here's the question. The question is, when you first start off as a programmer, as a developer, as a software engineer, what type of task are you going to be given with? 2 choices. 1, you're going to do tech support and figure out how to debug a program. 2, you get off and say, okay, here's a new project. I want you to start new code and write this new program. Debugging, of course, they will give you a job where you'll be quote unquote doing tech support, when you answer phone calls or somebody is going to send in, email and other type of notifications and say this program crashes. They give you a case number, you go to a bug tracker program, and you go like, oh, okay, this is the reproducible bug, this is how you can make the bug happen over and over again. Okay? And your job as a beginning developer is to fix it. So for people who hate debugging, they won't get past that stage of employment. And why do you think companies, ask newbies to debug programs? Well, okay, first of all, it's a filter, okay? It's kind of like, Gandalf in the movie, standing on the ridge, and the monster is on one side, and he kind of knocked his staff and go, you shall not pass. That's basically the first idea, okay? But the second one is to get the new employees familiarized with the product, okay? Nothing get a new employee familiarized with the product than debugging it. Because now you have to track down everything. You have to read the source code and track it down. Okay? And this will help. Okay? This type of reasoning, okay, the line of reasoning is going to be helpful when it comes to debugging a program. Okay? I personally actually like debugging a lot. Okay? If it's my bug, it's okay, we all make mistakes. If it's somebody else's bug, even better, because I'm finding out somebody else's mistake. And sometimes it will take days, okay? To debug a program is not something that is predictable, okay? I remember one time, in my previous job, there was a problem with a chip, okay? This is the combination of a chip, the hardware and also the software. As it turned out, somebody wrote the original code not reading the manual correctly, okay? There's one operation where you have to do part A first and then you do part B, because of the way the hardware, the transistors are designed. But this person did not read it carefully, and he did it in the opposite order. He did part B and then part A. But because of the way the silicon, the chip was designed, it was still okay. It generated what we call a race condition. In other words, it depends on the pathways between the transistors. If someone gets to this point first, then it works. If it doesn't, then it doesn't work. Okay? But as it turns out, the old version of the chip just so happened to make it work. So this bug was hidden for years. We're talking about 5-6 years. And then one day, they changed the die. Okay? We got a new batch of chips, which according to the manufacturer, should be 100% compatible with the old version. But that is only if you read the documentation and do everything as suggested, which the code did not. Okay? So the program broke after we soldered this chip onto all of the products and have everything shipped. People realized, hey, this doesn't work. And this product was already deployed in the field. So you can kind of imagine our marketing and sales people got really antsy because they are the ones who have to answer the phone calls from people coming back and say, hey, this doesn't work anymore. What is going on? And they came back to me and go like, okay, we need to fix this problem. Obviously, we have to fix the problem. So now the question is, how long will it take to fix the problem? So you guys play the marketing or the salespeople. You're getting all the phone calls. You're on the hot seat because you're the contact point with the customers. And you know that I'm the only person who can debug the program. What are you going to do? Come back to my office every 30 minutes and ask me, Tack, how's the debugging? We need it fixed yesterday. Is it fixed now? And do it every half hour? Or do you just leave me alone and just think, well, when it's fixed, it is fixed. It is fixed when it is fixed.
If you're a marketing guy, you come in every half hour.
That's exactly what happened. Okay, the marketing guy who was a 6'2", football player, came to my office every half hour and say, Tack, we need this fixed, yesterday and last week, what is going on? You're too slow, blah, 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 blah. You're drinking too much coffee, don't go to the bathroom. Okay, and then eventually it was the sales manager, at the same level as the marketing guy who told him, it's like, okay, I won't mention any names, dude, Leave him alone, okay? You're just delaying the process. He's already working as hard as he possibly can. Okay? If you keep interrupting him, it will just take even longer. It took me 3 days, by the way, to find that one because it was a good mystery. I had to do a lot of things to test it and say, can I even get here? Can I get here? Can I get here? Because that code was not in a regular program. It was in what we call the BIOS or the firmware of a particular product, which means it cannot communicate with anything at that point. The only thing I was able to do was make it to light up an LED or not. That was the only tool for me to debug that particular program. So it took me about 3 days to figure out, oh, so that's what it was. Anyway, that's kind of the job that you can kind of expect as a beginning developer. They call it basically, they'll give you a toothbrush and you have to clean the bathroom. Okay, that's the kind of way that some people describe it. I personally really like that sort of thing. It's like, oh, let's find out what the problem is. It's like reading a detective novel and trying to figure out who did it. Any questions? No questions? Okay. So I'm assuming that you guys are feeling kind of comfortable with this stuff. Okay. So if you're comfortable with this stuff, I won't have enough time today to go over that because we only got 5 minutes left. But what I can show you is what you can do. Okay. I have the practice exams unlocked. I think I'm going to unlock this one too. Okay, so let me see right here. Show. There we go. So the first one is just a PDF. Oh, ignore that. Okay, so it's really just a PDF or it's just a file, and I want people to do the tracing, with some of these. This one I want people to derive the pre and post conditions. I think the answer is actually interleaved already with the answers, so you might want to just read the question and try to figure out the answer on your own. So this is one. Here's one more. Okay. Once again, you have the question, and then the answer is already here, but don't look at the answer. Try to derive the solution yourself. And let's see. There's also more here, okay? So there's practice exam number 1. This one is a PDF. Now the PDF is particularly useful because it also shows you the basic stuff of my exams. It is going to be open book, open notes. The exam is going to be 1 week, exactly 1 week from the practice exam. Today doesn't count as a practice exam, so we'll do the practice exam on Wednesday, which means the first exam is going to be next Wednesday. So you might want to put it down on your calendar just to remind yourself that we have an exam next Wednesday. It will be open book, open notes. You can bring anything that is either handwritten or printed. Okay, so if you find a particular screenshot to be useful, hey, print it out, bring it with you. If you find 20 books, that you find is useful, bring them in. Okay, you can bring my solution to all the homework assignments. Okay, that's fine with me. You can bring anything that you personally take notes. You can even work together. Okay, make a little study group of 4 or 5. Study together, and you guys can come up with the same material to bring to the class. The only thing I do not allow, there are a few things. One is the use of electronic devices other than a simple calculator. So that is going to define a scientific calculator, the one that you're holding. Is that a TI calculator or is that a notebook? Oh, that's a planner. Okay, it looks like a calculator from here. Okay, so a scientific calculator is okay. I don't think you would need it. Okay. Cell phone is not. Okay, a cell phone is not okay. The computer is not okay. Okay, so a full computer is not okay. Everything has to be on paper or just a simple calculator. But other than that, there's no limitation of how big of a pile of paper you can bring with you. I personally would not bring in a lot of stuff. I would go through all the material and condense everything to my own notes and bring that instead. Yep.
Up to what topic number do we really cover?
Well, at this point, we have covered everything up to pre and post conditions, so the entire topic 3 is already discussed. So that's why you might want to bring questions. regarding the pre and post conditions on Wednesday, because that's the last topic of the exam.
So that's the cutoff, the pre and post conditions.
It will be including the pre and post conditions. Yep. Yep.
Any homework?
I don't have any homework at this point, but I can think of some and give you guys homework on pre and post conditions, because I think you guys need some practice.
Yeah.
So I will send an email to all of you when I have it on the Okay, I have not done that.